This is the first of our GCSE Further Maths probability videos. In this video we're going to be looking at the general rules of probability. We'll be looking at two-way tables and we'll be looking at Venn diagrams. So first of all, the rules of probability. The first rule is if events A and B are independent. So what that means, first of all, if A and B are independent means if the probability of A happening does not have any impact on the probability of B happening. So A happens doesn't make a button of difference to B happening. And if that is the case, then you can say that the probability of A and B is equal to the probability of A times the probability of B. So we're just going to look at an example of this. So it says in this example, what is the probability of rolling 3 5s using 3 fair dice? So really if we write this out, that's the probability of rolling a 5 and a 5 and a 5. So that's just the same as the probability of getting a 5 times the probability of getting a 5 times the probability of getting a 5. And if there are 3 fair dice, they get a 5 in the first one, it's 1 over 6. They get a 5 in the second one, it's 1 over 6. And they get a 5 in the third one, it's 1 over 6, which works out to be 1 over 216. Next thing we're going to look at, it says here, if A and B are mutually exclusive, that means they cannot happen at the same time. So if A and B are mutually exclusive, so this is for mutually exclusive events, the probability of A or B happening is equal to the probability of A happening plus the probability of B happening. So this only works for mutually exclusive events. So in this example it says, what is the probability of rolling a 3 or a 5 on a fair dice? So first of all, are these mutually exclusive events? And they absolutely are mutually exclusive, and that's because you cannot roll a 3 and roll a 5 at the same time when you roll a dice. You can either roll a 3 or a 5 or something else. So we're just going to write down first of all, probability of a 3 or a 5 just equals the probability of a 3 plus the probability of a 5. The probability of a 3 is 1 over 6, probability of a 5 is 1 over 6, which works out to be 2 over 6. And a very important thing in probabilities is to cancel down. So top and bottom divide by 2 to give you 1 over 3. The probability of an event A not happening. So the probability of A not happening is 1 minus the probability that A does happen. And that really is because they cover A happening and A not happening covers all the possible outcomes. All the possible outcomes, remember, adds up to 1. So 1 minus the alternative is going to give you a not A. So in this example it says, what is the probability of not selecting the 3 of spades in an ordinary pack of cards? So first of all I'm going to say the 3 of spades, probability of actually getting the 3 of spades, let's work that out. So the 3 of spades is one single card. So that's one card out of 52. So the probability of not 3 of spades is equal to 1 minus the probability of the 3 of spades, which is 1 minus 1 over 52, which is 51 over 52. Next bit of note says, if events A and B are not mutually exclusive, that is, that they can happen at the same time, then A or B, and this is a very important formula, A or B, probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B happening. So in this question it says, this is a formula you must learn. And another way you could write this as well, by the way, this bit A union A or B could be written as a probability of A union B. So you could write that way as well. So probability of A union B is probability of A and the probability of B, and another way of writing probability of A and B is probability of A intersection B. So that's not a U, it doesn't have the wee vertical line here, it doesn't have that. Let's get rid of that, it's just A union B. Likewise, that's not an N, it doesn't have a vertical line, so it's not an N like that, it's just a wee N without the vertical bit. So A union B is equal to probability of A plus probability of B minus probability of A intersect B. And then we can fill this in. So the question here asks us to find the probability of A and B. And it mentions A or B, so let's just write down your formula. So the formula is going to be probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And from experience, I would have preferred to have rearranged this to make probability of A and B, A intersect B, the formula here, the subject here, but from experience people prefer to just fill it in and then we will rearrange. So 1/2 is our A union B. Probability of A was 17 over 30. Probability of B is 1 over 5. And then what we're trying to find is the probability of A intersect B. Now we will rearrange. So I'm going to say my probability of A intersect B, bring it over to the left hand side, is 17 over 30 plus 1 over 5. And then this half now comes across. So it becomes minus 1/2. And then we've got probability of A intersect B is equal to, so you do that all in your calculator, and I have got 4 over 15. Now we're going to look at two-way tables. Now two-way table is very straightforward. It says, in this example, we've got a whole pile of different papers. You've got digital versions or paper versions. You've got Mail, the Guardian, the Times, the Independent, the Telegraph, and the Newsletter. So how many people read the Telegraph? So the Telegraph, just these two. So it's just going to be 43 and 34. So it's going to be 77 people. Next bit is 50 people read the Guardian. How many people read digitally? So these two things, whatever this missing thing is, plus the 21 adds up to be 50. So we're just going to say, to work this out, it's going to be 50 minus 21, which is just going to be 50 minus 21, which is just going to be 29. So we can now fill that in on our table. And the next bit says the Independent is the most popular newspaper by 10 papers. How many people were surveyed? So it's the most popular newspaper by 10 readers. So the second highest number then would be this one, which is 49. It is the most popular newspaper, so that's incorrect what I've been saying. We've got to work out the totals for each of these, so we'll work out the totals, because you can read a paper by reading the digital version or the paper version. So if we do the totals here, 49 plus 26, 40 plus 20 is going to be 60. And then 9 plus 9 is 69, plus another 5 is going to be 75. 21 plus the 29 is going to be 50. And 40 plus a 10 is going to be 54. And we don't know what the independent is just yet. And then 43 plus 34 is going to be 77. And 36 plus 21 is going to be 57. So it's the most popular paper by most popular newspaper by 10 readers. So our second biggest one then was 77. So we'll just say needs to be 10 more than 77, i.e. 87. And so we'll just say, we'll just do 87 minus this 31, and that is going to give you 56. So that's gives us 56 then. So how many people were surveyed? We've just got that 56 there. We don't really need to do that, but that's 56. Read it digitally. Okay, what the question actually asks you for is how many people were surveyed. So we can just total this 56 and the 31, which is just going to give you the 87, and we can then just work out your overall total. So your overall total here, if you just add those all up, so overall total is going to be 75 plus the 50 plus the 54 plus 87 plus 77 plus 57, and if we do that on our calculator, we should get, and it's going to be 400 people. And that's it. Venn diagrams. A Venn diagram uses circles to show how different groups overlap. You've maybe seen these in different things, in different subjects, maybe in science, maybe in geography, and also down the school you may have used them. There's a Venn diagram method you can use for finding the highest common factor and lowest common multiples. We're also going to use it for finding probabilities. So let's just jump to this example, see how this all works. So first of all, there are 70 girls in year 11, 40 play netball, 25 play hockey, and 12 play neither. Draw a Venn diagram to represent this data. So, okay, first thing we're going to do is draw a rectangle. Inside this rectangle, you're going to have a circle, which represents hockey. You're going to have another circle, which represents netball. And outside, which is what we're going to start with, is the 12 people who do nothing. So they don't play either of these sports. So there's a 12 that play neither. So that's where that 12 comes from. So that 12 is very important because 12 play neither. So that means 70 minus 12, which is 58, play either hockey, netball, or both. Okay, right. So hockey, first of all, hockey is this wee shaded bit in here. Netball is this wee shaded bit in here, and both is this wee overlap in the middle. So that's what we have got. Oops, just get rid of the circle. So what we now know is that these three things combined add up to be 58. So we now need to figure out a way of working out how these things are proportional. Okay, we're going to look and we're just going to think how we actually work out the wee bit in the middle, which is both. So we know we had 40 people play netball, 45 people play hockey, but we know there that the amount who actually play anything is going to be 58. So if you add those two, you're going to get 85, and then take away your 58, you're going to get 27. So 27 is what goes in the middle here. So I'm going to make this overlap bit a wee bit bigger so I can write in it. I made it much bigger there, but we're going to put a 27 in here. So that's how we've calculated that 27. How we can calculate the rest then? So just say only hockey. So this is part one then. Only hockey is going to be equal to. So your total for hockey was 45. So if you do 45 take away 27, 45 take away 20 would be 25, take away another 7 would be 18. So that 18 can now go in here. And what the question asks you for part 1, it asks you to find the probability of hockey. So the probability of hockey, so P of H is 18 out of our total, which is 70, which is going to be 9 over 35, and that is as good as we can go for our probability. We can't cancel down any further. And same idea, we can say for part 2, what we need to work out first is the number of only netball, which is your total for netball, which is 40 play netball, and minus your 27 overlap. 40 minus 20 is 20, 20 minus another 7 would be 13. So you've got 13 in here, and then your final probability that somebody plays hockey or netball or both. So hockey or netball or both is this whole shaded bit, that the overlapping circles, that's what we're looking for then. And that's what we're looking for, so the plays hockey or netball or both. So we'll just say hockey or netball or both. Number-wise is 18 plus 27 plus 13, which is going to be 27 plus 13 is going to be 40 plus 18, sorry, is 58. So your probability, and how you write it, is probability of hockey, union, netball, because that's what that means, hockey, or netball, or both. And that is 58 over 70, which a wee bit cancels down to be 29 over 35, and that's as good as we can go. Apologies for how messy that was. That's it done. Okay, in this example, which is our last example for this video, it says there are 60 teenagers in a youth club. 29 have a pet dog, 21 have a pet cat, 15 have a pet rabbit, 9 have a cat and a dog, 10 have a dog and a rabbit, 11 have a cat and a rabbit, and 7 have all three. Part 1 says draw a Venn diagram to show this information. Okay, this can feel a wee bit overwhelming. An example to guess. You have an awful lot of information, so we're going to give you a wee trick how we do this question. To do this question, first of all, you draw your 3 overlapping circles. So you've got your dog, you've got your cat, and then you've got your rabbits. Okay, so the size of these is relevant. It's just to get them drawn somehow. And what you want to do is you want to start with the overlap of all 3 and work out. So it says 7 have all 3. So 7 is a number that goes in here. And then you work back. So 11 have a cat and a rabbit. So a cat and a rabbit, if you can just see what I'm sort of circling around, cat and a rabbit is this overlapping sort of oval. And the 7 plus the 11, 7 plus this missing number here have to add up to 11, which means this number in here must be 4. Okay, work back again and see what we've got. So it says 10 have a dog and a rabbit. So dog and a rabbit is going to be in here. So dog and a rabbit is going to be this wee bit in here. So that means we're going to have a 3 in here. Next thing is 9 have a cat and dog. So the only remaining overlap then is a cat and a dog. So that's 9, so that means this bit number must be 2. Okay, we've done the overlap of all 3, the overlap of 2. Now we're on to the only one things. So it says 15 have a pet rabbit. So that means 3 plus 7 plus 4 plus this mystery number must add up to give you 15. So you do 15, take away 3, take away 7, take away 4. And if you do that, you will get 1. Next thing it says is 21 have a pet cat. So same idea. To get this missing number, you do 21, take away 2, take away 7, take away 4. And when I did that, I got 8. And the last thing it says, 29 have a pet dog. So this number in here is going to be 29 minus 3 minus 7 minus 2, which is going to be 17. One more bit of information for us, and it tells you there are 60 teenagers in a youth club. So all of these numbers that I've just put down, plus some mystery number outside, must add up to give you 60. So to get this number outside, you do 60 minus 17 minus 2 minus 8 minus 3 minus 7 minus 4 and minus 1. And when I did that using my calculator, of course, I got 18. You're now ready to answer whatever the question could possibly ask you. So it says in part 2, teenagers chosen at random find the probability that they have a rabbit but not a cat. So a rabbit but not a cat. And so we'll just say rabbit but not cat, or but not C. So a rabbit but not a cat. So your cats are there's your rabbit circle, and the ones that are not overlapping with the cat are the 3 and the 1, which is a total of 4. So that's 4 out of, and our total number of people was 60, which top and bottom divide by 4 to give you 1 over 15. Part 3 says find the probability that somebody has none of these pets. So probability none, and that was this out here, this 18. So it's just going to be 18 out of 60. top and bottom divide by 6 to give you 3 over 10, and again that is us done.